Hello. We need to continue, right? Where we are now is the level where now we are doing the application. These are practical problems, and mostly where the problem comes, they always, most of the times, try to ask you problems which are applied. So at least you have to take this section, very important. The first part of the application, before we have the last one about the bearing, is about the angle of elevation and depression. Right, so in the previous video, you can use the link down here to at least remind yourself of what we've been doing. Try at least to go through, if you talk of angle of elevation, what is it? If you talk of angle of depression, what is it? It is just self-explanatory by what we discussed. This time around, I want us to take ourselves through into the problems which needs us to apply the issues about angle of elevation. Just maybe take it up. Angle of elevation is the angle that we use to see something on the top, and angle of depression is the angle that we use to see something downwards. So see what is there in the videos. The questions of which we should expect are such questions like the one I have here in this chart. So I have some examples too of them. So allow me again to remove this title. Right. So you can copy these questions somewhere. All right. Right. So we told that you have a man whose height is 1.8 meters. So the man is just 1.8 meters tall. So here, whenever we talk about the height of a man, we are referring to distance between the toe, or say talk of a foot, up to the eyes. Target is not on the forehead, but now we talk of the eyes. That's the target, from the ground level to the eyes. So that should be the issue, how we are about the what? About the heights of a particular individual. We target the eyes. Why we talk of this one? Remember about what we have been discussing earlier when I introduced the angle of elevation and depression. Is all something that has to do about the sight. So that you twist your head up and see something, you twist the head downwards and see something here. So here we are referring to the eyes are 1.8 meters from the ground. So this man, say, is standing looking at the top of a tree. He is 20 meters from the base of the tree. He measures the angle of elevation and finds it is 35 degrees. They say, how tall is the tree? So here now we're looking at the length of the tree. How tall is the tree? The height of which. Right, so based on what we have just discussed and what we know about the trigonometry, or what is here is about the right angle triangle. So which means you're first of all going to produce the sketch of this or passage and then see the direction of which. So what you do here, firstly, you can have at least somewhere, script somewhere, and try to produce at least more like a real experience in the row diagrams. Then after, you can now at least present those diagrams in the form of lines in order to produce the shapes that we need, and then have the triangles within that and work out the problem. So like here, talk of the tree, I can now figure it out, and maybe this is a tree, thing like that. And say there's a man, the man can stand, that's the thing as 20 meters from the base of the tree. So I can have here the distance here from the base of the tree. this is 20 meters, and the man is here. They say this man, this is the man, is looking up on top of the tree. So this is the top of the tree. I can have it with letter T, so it means his sight is focused on that. See that? Underneath, they say the angle of elevation of the top of the tree is 35. So the angle is always formed between two lines. So one, it is the line of sight, and the other line is the line which is original when that man is not interrupted. So always should have a normal line of sight. So normal line of sight and the line that is using to see or observe what is on top of the tree, they form an angle. So this angle is used to see something on top. So it's more like this man is twisting his head upwards and see what is on the top. So this is the angle of elevation and indicate it 35 degrees. That is the situation. A man is 1.8. It means from here to that is 1.8 meters. That's how we interpret. So make that this one, ground level, is parallel to the top of the normal line. We should expect that, say, this tree again has got a line which is just like representing it, just like a side, and the man is also represented by a certain line. Take that here in the normal circumstances, as far as this tree is on the ground, we are looking at the height. We should expect that the part of the height of this tree is represented by this line from here up to that, and we expect this one to be light angle, the height. The same man, if talk of is 1.8 meters from the ground, we have to consider that the man is perpendicular to the ground level. So expect this one also to be perpendicular. So if this line is parallel to this one, we should expect that, say, as much as the angle is 90, this one should also be 90, this one should also be 90, in the normal circumstances. So which means if I talk of the shape which is going to be formed here, it will be like more like what? A rectangle, right? Whereby the opposite sides must be equal. Then if this is 1.8, we should expect that this one should also be 1.8. So which means part of the height of this tree is 1.8. What will remain here is only this other part here. What is this from here up to that? That will be a target. So if this is 20 meters, again from here up to that, we should also expect this one again to be 20 meters. It's more like the opposite sides of the rectangle are equal. This side is equal to that side, this side is equal to that side. I think you are aware of the properties of the what? Rectangle. So that's the way it is. So let me just go through again. The first thing to analyze the passage here, come up with the real life diagrams, have a tree, have a man, produce everything line of sight and the like. Then after try to present everything by lines. So here, a line from here to that is representing a tree. This line I have here is representing a man. This line I have here, 20 meters from the base, that is representing the ground level. And this line here I have here is the line representing the normal site. But this line here is representing the site that is using to see the top of the tree. Right, so originally what we need here, basically what we want to do is just find the value of distance from here up to that. From here up to that. And this distance should be added with this length, which is 1.8, which is just like the height of a man. So it means just like 1.8 plus what we have from here up to that. If this is maybe whatever, you can solve T, TP, or just represented by a variable X or H, things like that. So that's the way it works. Right. So it means my diagram that will produce out of here, it'll be a diagram which will go like this. This is my man. You can have it this way, like this one, and then go up like that. Let me draw something that is much bigger so that you have to see what I'm trying to explain. I'm not interested to solve the question, to give you the answer, but I'm interested to give you a direction on how you can approach such questions. So that's what we do. So here, level ground is this, height of a tree is that, height of a man is this. So this is the normal side, and this is the side on top of the tree, and this is the angle of 35 degrees. This is a man, can have it, maybe talk over PX. This is the D, M. Let's have this one as M. Here also let's have M. And on top here should be T. So this is 90, this is 90, 90, 90. So if this is 1.8, this is also 1.8. We don't have TM. Distance from here to this is 20 meters. This one again is also 20. So what we need to do, let's just find Tm. Find Tm, we add 1.8. We have the height of the tree. Right. So it's like now, by what I've learned, I'll be able to realize that this triangle we have here, from here up to that, Tm, let's have this one as P. This is X, TMP, or TMP is right angle. Such that if I want to find the value of Tm, definitely I can use this Ogatoa and choose which ratio is worthy to find that. Right, so from this, you'll be able to see in the position that say, as I mentioned, to choose the ratio, try to determine what is the side name of the side you'd like to find. So like here, the name of the side here, you find the side that is opposite 35 degrees, so you have the opposite side. And what is the side you already have on that triangle? So you find that here you already have the 20 degrees. What is the name of that side? You find that this side is adjacent to 25 degrees. So you have got the opposite and adjacent side. These two sides give us the direction that the ratio to use is the tangent. So here we are. We talk of the tan of 35 degrees is equal to opposite, that is Tm, to what? Adjacent, which is 20, like that. So which means in this case, we talk of our Tm is equal to 20 multiplied by tan over 35 degrees. Right, so if we do that, we'll be able to realize that the tan of 35 degrees is 0.700. So once you multiply that, the answer you're going to get from there is what? 14.0 meters. Right, so that's the way it goes. So it means the distance from here up that is 14. But now what we want is the distance from here up to that is the height of the tree. So which means to find talk of the TD, right? The whole of this distance here, you have to add 14 plus 1.8. So that's what we're going to do. So from here, we go like a conclusion to say, therefore, the height of the tree will be equal to 14 plus 1.8, that's meters. So this gives us what? 15.8 meters. So it means the tree is 15.8 meters tall. Right, so that's it is about the elevation. So I know you can take note of this one and be able to understand how these things work. Right, the next example. It's more like again the same, but this one a bit of application is required. So I'm going to give you two phases of questions. Some need a little bit of application, some the ones which just come direct, such. Right, so we have the second one where we're told that the girl who is looking at the top of the building, she measures the angle of elevation of the top of the building as 40 degrees. She walks 20 meters towards the building and finds that the angle of elevation now, of course, if you're approaching a particular object and you look at the top, always the angle increases, the one you used to see something up because you twist the head more to see on top. So it's 55 degrees. The girl is 1.5 meters tall, and we asked her how far was she from the building when she started. A distance there. And lastly, how tall is the building? Right. So as usual, for you to approach these questions, they work better if you have a sketch diagram first. So what do we do here? We'll have that situation. If talk of a building, now I'll go direct into business, that at least drawing all those buildings and the like, I've already given you that guide. So whatever I'm going to draw about that, I expect you to produce a diagram which look more like this. Height of the building is more like this one. Let us try to consider that the building is represented by this line. Let's move this way in here. The building is represented by this line. So this is our building, the height of the building. Let's have this one as the TM, and represented by maybe letter D. And the ground level where this woman is walking towards the building can be represented by this line, right? So you can say, you can talk of the initially, the woman is here, right? But now this woman, tentatively, we can have it something like this. This point is more like the position of her eyes. So it's more like the ground level is this one. If we were to extend further the diagram, so it'd be more like this. Talk of the MH. So KD, that's the height of a woman. Right, but TH is the height of the building. This level is just like a demarcation of part of the height of the whole building is the same value of the height of a woman. But rather the building is TH meters tall. Right, so the woman is 1.5 meters tall in this case. Right, so it'd be like a woman is walking here. She has walked talk of what 20 meters towards the building. So it means from where she stands up this level, let's consider this one as 20 meters. And the rest other part of the distance is not known. So you can represent that distance by any value like, let me use this one as H because of the height, and use this one as a D different radar. So usually height should be for the building. Let me not use that one out. Right, so it means that from the initial position, she walks 20 meters, and we are not told the other part of the distance that she walks, right? But we are given that the angle of what? Elevation that she used to look at the top of the building is 55. So now, the fact that the top of angle of elevation, we expect the angle of elevation to be produced from this D here, because this is the position of our eyes, to go upward there. So the line of which should be represented as such, like that. So it means the angle of elevation is this one here, 55 degrees. So if we're going to analyze the situation here, if we can leave this part here, we'll be able to see, first of all, that say, if we talk of the distance from here up to that, is as good as having from distance from here up that, because the opposite sides here are all just the opposite sides of the what? A rectangle. So if I talk from here up to that, it's as good as I talk from here up to that. If this is 20 meters, so this is also 20 meters. So I can leave this one out first, the ground level, and concentrate on the line of sight, according to the way the question has been presented. So we can consider 20 meters up to this level. This is just a D. So we know for sure that the woman is 1.5, the same here is 1.5 as part of the what? The distance. So let us leave this one behind first, how they will be discussed with that one later. So in the normal circumstances, this is what we have. So it means in this case, if the woman walks further, it means the angle of elevation changes. So the line of sight is here, angle of elevation 55, and then she comes again, angle of elevation, no, the first one is 40. We are told that that is 40, from a distance is 40 degrees, yes. But now if you're close, this one should be 55 degrees. Let's take it that way. Right, I get closer towards the building, the angle of elevation increases. I'm far, angle of elevation what? Decreases. Right, so what we have here, we are asked to find the value of the height of the building. And secondly, how has she walked to move the distance from what she started? So here, if we are to respond to question 1, by this what we have here, we should expect that when they say how far was she from the building when she started, it means we are looking for the distance, which is number 1. We have to find what? dm, which is as good as the 20 plus the value of a d. How far was she from the building when she started? So it's more like you have to find the value from here up to that. So which means you have to have 20 meters plus d. So what is there? Just calculate the value of what? Calculate the value of a d. Secondly, the next of the question, they're asking us to find how tall is the building. Here, it means we have to find the value of h. So it will be h in this case, which is tm. Let me write this case as a tm plus. Remember, this is the woman here. She is 1.5 meters tall. So it means somewhere, as much as she's 1.5 meters tall, we expect the building to go further like that. So if this is 1.5 meters tall, so this one should also be 1.5 meters. Opposite sides of the what? A rectangle, which are produced by the what? The woman here. So if I'm to work out the value of the height of the building, I should consider Tm plus 1.5. So it means you have to have Tm plus 1.5, where Tm is h. So it will be h plus 1.5. Right, that's what we're going to do there. So what I'll do here for this problem here, I'll just give you the guides I'll need you to work out on it. Right, that's what I have here. I'm just trying to summarize it for you. So try to calculate based on what I'm trying to explain. So what is needed on question 1? You need just to find the value of a d, and that d should be added with 20, and that's the distance of the woman from what she started. Secondly, how tall is the building? We are talking of h plus 1.5. So please calculate the value of what? h, and you add with what? 1.5. Right. So in your calculations, I would expect you to find the following solutions. You do it and then try to find them out. For A, where we talk over 20 plus D, please find it that the value that you have from there is 48 point what? That is 5 meters. So that is the distance from here up to that. So please do the calculations and see how best you can find 48.5 meters. If you're not finding this one, it means you have done it wrongly. Try to think about this. I need to be applying maths, so try at least, but not difficult, just simple. For part B, where they're asking you how tall is the building, I've already explained, is h plus 1.5, which means whatever find for h, add with 1.5 for the height of the woman. So the answer to be expected here for h plus 1.5, the answer that I expect you to find should be 15.8. So which means the height of the building is 15.80 meters tall. So I think this now works better. I've given you the first question as an example I've done together with I. The second one, can you do it on the exercise, and more I've given you the guides. Right, so this, my dear students, both level, mature, talk of parents, and also students on the lower level, is where we end the first part of our application. There's only one last part of the topic that is about the bearing, very sensitive. So that is the part that is going to lap up the entire topic. So we'll have that one in the other videos. 2 videos are enough, just 2 lessons are enough for that. Thank you very much for being together. Thank you.